Okay, okay. We're going to start with prisms and cylinders. So, we're going to start with prisms. These are all prisms. Can I share your desk? Thank you. This is a triangular prism. The base is a triangle. And if you extend that triangle upwards, you get what's called a triangular prism.
You have a person.
Hello, person. Not one of mine. Yep, I got the other ones taken care of though. Thank you. So, triangular prism. Triangular. What would this be? Hexagonal or hexagonal prism. This one's a little bit of a problem. What's this?
Rectangular prism.
Rectangular prism?
Yes.
What shape's the base?
Square.
So what would this be?
A square prism.
What's this?
Now it's a
But
rectangle.
Arnold,
Prism.
Arnold, what'd you call me?
No, aren't all
Oh,
squares rectangles and rectangles aren't all squares?
that's true.
So that isn't just a rectangular prism.
Well, why wouldn't it just call that a polygonal prism? Because all triangles are polygonal.
I mean, I guess you could.
You could.
Well, we didn't have enough information to know that it was a square.
You don't have enough information to know that it's a square?
We didn't measure it yet.
What are you eating?
I thought that's
What are you eating?
Sorry.
As you shove another one into your mouth. What are you eating?
M&M's.
Do you have enough for everybody?
Yeah. Probably.
Okay, go ahead, distribute them. So there's a problem with this one because sometimes the base is a square and sometimes the base is a rectangle, so we avoid that by just calling this a box. As opposed to this guy, what's this?
A cube.
A cube. How does this differ from this? Nathan?
They're equilateral. The cube is.
The cube, what's it? I don't like pronouns.
The cube is equilateral.
The cube is equilateral, meaning what?
All sides and bases.
Good. Okay, so those are all prisms. Sometimes, however, well, you'll notice with all of these prisms, they have one thing in common. The sides meet the bottom at a right angle. These are called right prisms, as opposed to this guy, which is not. Okay, we'll get to this in a second. This has a fun name. No, thank you. Appreciate it though. Especially after you've touched it. Okay, these surfaces that make up, let's do the easier one first. Okay, Amber, how many faces?
Faces.
Yeah, these are all faces. How many?
6, no more than 6. 1, 2, 3, 4, 5.
Beautiful, 5. Now, some of those faces are bases. How many bases?
2.
2. How many? Okay, so 5 faces, 2 bases. The other things are called lateral faces. Lateral meaning side. How many lateral faces?
3.
Hot diggity. How many faces?
Stop flipping around. Okay. 6. 10. I can't count. You're moving it.
Right in the middle.
8.
8. How many of those faces are bases?
2.
How many lateral faces?
6.
Good. How many edges?
16.
Nope.
I don't know. I don't want to count anymore.
You don't have to count. Use your brain. What shape is the base?
I don't remember. Hexagon.
Hexagon. And how many edges does a hexagon have?
6.
And then I got another hexagon up on top.
12.
And then I got all these edges around the sides. How many edges do I have around the sides?
6.
6.
18.
18. Well done. Some of these edges are base edges. Some of these edges are lateral edges. And then we got the corners, which are, what's the name for corners? Vertices. Okay. How many vertices does this have?
Well,
Are you telling me or asking me?
telling you?
Telling me there's 12?
Yes.
Good job. Okay, let's see if you've learned anything.
No.
Come on, you're doing great. How many faces?
6.
Good. How many bases?
2.
How many lateral faces?
4.
How many? Yeah, okay. How many edges?
Yeah, 86.
86.
8.
8?
8.
8?
8.
8?
I can't be fast.
No?
I want to count anymore.
Come on, you can do it. I know it's so strange.
I think it's
You
8.
can take a nap after this.
6. 8. 10. I'm done.
So close.
Yeah. Give me that pattern.
12.
Hey! One more.
Oh my god.
How many vertices?
8, 10, 16. I'm really bad at pattern recognition. 12, 6.
We had it the first time.
6, 8. Okay, hold on.
68.
8. Why are you looking at me like that?
I'm amazed.
8.
8. Are you
What's the
sure?
question? No, what was the question?
How many vertices?
8.
8. Are you sure?
Yeah.
Are you willing to bet your grade on it?
No.
Oh, so you're not sure.
No.
Beautiful. There are 8. Okay. So, let's see what we got next. What's that thing, by the way?
Pentagonal prism?
I'm sorry, Nathan?
Pentagonal prism?
Beautiful. Pentagon or pentagonal prism. Its bases are pentagons, obviously, since it's a pentagonal prism. And then if we go through the things we already talked about there, it's got 2 bases, it's got some lateral faces, it's got some base edges and some lateral edges. Now we get back to this guy. So the difference between this and this. This is a right prism because the lateral faces meet the bases at a right angle. This is not. This is called an oblique prism. Okay, it's slanted. This actually, what shape is the base? Parallelogram. This is called a parallelepiped, which is fun to say. Try it. Isn't that a fun word? Yeah.
How do you spell it?
It's like
Parallelepipedjkdlm. I'm sorry?
So close.
Okay, well, I think that was right. Yes.
So right prisms make 90-degree angles between the edge and the vertice? Okay.
And most of the work we're going to do is going to be with right prisms, but we will throw some oblique prisms in there just to see how you deal with that. And notice that just like we had triangles and stuff, the right prism, or the oblique prisms will have altitudes as opposed to just using the edge. Notice in this, the edge and the altitude are the same, but in this, the edge and the altitude are not the same. Okay? How are we doing so far? Good? All right. A lot of terminology. What's this thing?
A cylinder.
Good. It's a cylinder. How many faces, Erica? 2. Yes?
Yeah.
What about this guy? Are you saying 2, 1, 2? But you don't want to count this side thing? Okay, that's fine. Everybody on board with that? Alyssa, you're shaking your head vehemently.
I think the other thing is a face.
This is a face? What's a face?
Can you define it yet? Or am I?
No, I'm asking you. What's a face?
A part of the prism.
A part of a prism.
I don't know how to define a face.
Anybody have a definition for a face? Stop eating.
I thought you said if I share it, I could.
You have more?
Well, like 6 or 7.
That's not enough for everybody. Give them to me. What's a face? Go ahead.
The area between between two bases. Edges.
The area between two base edges.
No. The area between, okay, the area connecting from the edges of a base.
But isn't a base also a face?
Yeah.
It's not horrible.
Yeah, I mean, it's a good first try.
Yeah.
Like a planes that make up a prism, or I don't know. They're planes, right?
Okay,
Yeah. All kinds of fun.
you got planes,
Yeah,
and she's got areas.
yeah, like they're planes that make up a prism.
Does a face have to be flat?
No.
No?
I mean, if it's a plane, yes, but if we are counting that circular, or the not flat part of the cylinder as a face, then no. I don't know.
Well, we haven't established if
Yeah,
we're counting
I
this as
don't know.
part of.
Yeah, I don't know if they are.
Let me rephrase the question. How many surfaces does this have? Three. 1, 2, 3. So we're debating whether or not this is actually a face. And you're saying no?
Yeah.
Anybody want to jump on that bandwagon? How many people agree that this is not a face? Couple. The rest of you think it is a face? Okay. Interesting. All right.
Is it?
I don't know, is it?
Are we gonna
Is this
go
one
further
we
on
get
this
that
petition? Should I write it down?
Well, we're not, we did that already. Well, let's do this first and then we'll come back.
Okay.
All right, so we have something called a net, and a net is a two-dimensional representation of a three-dimensional object. In other words, if
Bless you.
that scared the crap out of me. If I want to make a this is three-dimensional. If I want to make a box out of cardboard, for instance, I could cut out a pattern and fold it up, and I got a box. What does that pattern look like? So draw one.
Pattern for
Draw a pattern that you could fold up into a box,
Oh my
into
gosh,
this
so-
thing. What?
These are like on standardized tests and they tell you what shape it is.
Wow,
Oh.
a lot of negativity coming out of you today.
Your box, your something looks like a smashed up cube.
an insult.
No.
Now she's just getting mean. I mean, it was stressed before, but now she's just turning on. There's a big viper. One, two, three, four, five. I only got 5 here. How many are you supposed to have? Ooh, interesting. You got an extra square.
Oh shoot.
Most people are drawing it one way. Good, good, good. But there are a couple off the beaten path ones. Did I go that route? Oh, well, usually Branch does, but I think he went with the status quo today. So this would give us a net for that box. Not the only possibility. You could move these figures over. You could put one square over here, one square over there. You can pretty much slide them anywhere you want. You could stack the rectangles this way, which is what Camilla did. And then you've got, oh, that works. Okay, good. That also works. So there's a couple different options. Right? We good on the net? Every one of these polygonal prisms that we deal with has a net. Now the question is, what's the net for that cylinder look like? with the status quo today, huh? You got nothing else? Ran. Okay. So some variation on that picture. Okay. Tell me about the length of that segment right there. Where did I put my pen down? George, go ahead.
It's the circumference of the circle.
Beautiful, it's the circumference of the circle. For those of you that have trouble with visualization, I've got this high-tech demonstration. So here's the rectangle. You roll the rectangle up and boom, cylinder. Pretty cool, huh? I guess it's not that cool. It took me years to develop, thanks. My lifelong dreams dashed. I'm not gonna show you the other one then, you're not impressed. Yes, sir?
Couldn't it also work if like the bottom circle is directly beneath the top circle? So, like-
Over here?
Yeah, so it looks like this.
Sure.
Okay.
Like Fiona has Mickey Mouse ears. That would work also, right? Did you erase it? Just because I commented on it looking like Mickey Mouse, you went crazy and erased it? Wow, okay. And these points, or this circle would actually be touching the rectangle in only one point. It's not really like a flat surface like a hinge. Okay, so you roll that up. This distance, like we said, is the circumference, and that gives you the net. So seeing this, Erica, do you want to stay with that having only two faces?
No,
You want to change to 3?
yeah,
You don't have to, there's no right or wrong answer.
no, I think it's 3.
Those of you that said you were in Erica's camp, raise your hand. Are you jumping ship with her, or are you staying with only two surfaces? Or two faces?
Stay.
Staying. Why?
Because
It's America. Like, oh.
You can do whatever you want, thank you. Even though it's wrong. Or it could be wrong, I should say.
I thought you said there's no wrong answer.
In this case.
Yeah, I lied.
There's a more like,
So, what's the consensus? Are we going with 3?
yes.
3 faces? 2. You want 2 still.
yeah, because isn't a face flat?
Isn't this flat?
Now I want to roll it up into a cylinder because that's not a cylinder.
But if it's not a face, then what would it be? Because it's still there and it's still like a part of the shape.
Boom!
It's a surface.
Yeah, it's just a surface.
So then can't you argue that all of the faces are just surfaces?
Unexplored.
Well, they are all.
What's going on?
Just getting angry about the faces.
Well, there's another possibility that I'll throw into the mix. What about an infinite number of faces?
I was gonna say that, but then I just, I didn't want to bring it
You
up.
afraid somebody would mock you?
No.
Or that Caitlin would?
No, I was just afraid there just being, I didn't want 3 divisions.
But that's
That's very courteous of you. Thank you. That's what? You're done.
okay.
So 2, 3, or infinite?
3.
Just for giggles. Branch, what do you want to do? 72.
4.
She's gonna go with 4. 3 surfaces and then time. That's the 4th dimension. Great. Good job. Okay, let's move on.
Wait, what did we agree?
We didn't agree to anything.
So we're
Can
just
we
gonna
just Google it?
No.
Well, you can Google it, but because we know everything on the internet is true.
Essentially.
That's State Farm.
I'm sorry.
Yeah,
State
It's
Farm
a State Farm
commercial.
commercial.
Oh, yeah.
Oh, is it? I don't really
the
watch.
French model one.
Yeah,
Oh, I've seen that one. Bonjour.
yeah.
By George.
All right.
Oh.
Finding the surface area prism. So this chapter is broken into a bunch of different parts, and we follow the same pattern. We find the surface area of something first, then we'll talk about the volume, then we introduce some new shapes to find the surface area, and then we talk about the volume, then we introduce the surface area, then the volume. So today we're doing the surface area. 2 techniques you can use. I don't care which one you want to use. I have a preference, but I'm not going to force my preference on you because, again, this is America. Got the power right on. How could I find the surface area of that thing? Alyssa?
Find the area of one of the lateral faces, multiply that by 4, and then find the area of the base, multiply that by 2.
Excellent. That's the second technique, the one that I happen to prefer. Any other ideas? You probably wouldn't get the other idea without some coaching, unless Alyssa raised her hand and has some other idea.
Just think.
Yeah, this is gonna be all over in a second if I
Like a
give enough
rhombus
time.
in there.
I don't know if this is right, but if you take the net and then you find the area of the big rectangle and then the 2 squares, I don't know.
Pretty much a variation of
Kind
what
of
you
the
said.
same thing.
Yeah, Baranch would split this into 74 rhombuses. Find the diagonals of the rhombus, square each of those measurements, then multiply it by his age, and then divide it by the day of the week. And then for some weird reason, he'd get the right answer. All right. Well, the first method is a formula. I'm not a big fan of formulas, but you can use that formula. But before we start writing down the formula, we need to talk about the notation here. You'll notice some things changed. First of all, S stands for surface area. Capital S, by the way. Lowercase s stands for the length of the side in a regular polygon. Notice all of a sudden the B has become a question?
Isn't it capital S also semi?
No, that was lowercase s.
That was a lowercase?
I think so.
Yes.
Okay.
Capital B. Lowercase b meant the length of a base, like in a triangle. Capital B means area of the base. What's P? Perimeter. And capital H now becomes the height of a three-dimensional object. So lowercase h was the height of a two-dimensional object, like a triangle for instance. Capital H becomes the height of a three-dimensional object. Okay. So if you want to plug and chug into a formula, that's okay. Now the reason I'm not a big fan of the formula is because number one, I'm not a big fan of memorization. Number two, you have to change that formula based on the shape you're talking about. Notice if I'm doing a finding the surface area of a box, then base is going to be, in this case, the side squared. If the base changes, are these in your way, by the way?
No.
You sure?
Yeah.
Okay, feel free to play with them if you'd like.
Alright.
If the base changes, now all of a sudden capital B becomes the area of a hexagon. So, again, the reason I don't like the formula is because you start with the formula, but then you need to change the formula into another formula. And if you're going to do that, why not just go find the area of 4 rectangles and 2 squares? Okay. But again, I'm not going to force either method on you. You can do whatever method you want. And as we work through the examples, I'll show you examples of how to use both forms. Okay? Alternate approach we already talked about. Find the area of all the surfaces, add them all up. Whether those surfaces are faces or bases or lateral faces, or that rectangle that we get from the cylinder. One thing we didn't talk about up there is capital L. Capital L stands for the lateral area. What do you figure the lateral area would be? Leo?
The area of the lateral face.
Lateral area of the lateral faces, right? Does not include the bases.
Wait,
I'm waiting.
is it the area of all the bases? Or all the faces?
You said
Oh, wait.
Okay.
Unweight.
Okay.
Is it the area of the, all 4 of the lateral, faces or?
All of the lateral faces,
Okay,
but not the bases.
okay.
I'll give you the lateral area.
But it's not just the area of one of
No, it's the all of them. So the difference between the lateral area and the surface area is the surface area includes the bases, the lateral area does not. Okay, we ready? Here we go. Find the lateral area of that thing. First of all, Faith, what is that thing? I don't know. Hexagonal.
I don't know.
Hexagonal.
Hexagonal prism.
Prism, thank you. What were we having trouble with? The hexagonal or the prism?
The hexagonal.
That's understandable. You can't say that word, can you? Some words are like that.
Yeah.
No.
Thanks, Jackie.
Did she make fun of you?
Yeah.
Jackie, what's the sign say up there? ELE.
What?
ELE, everybody love everybody. All right, how do we find the lateral area? Dan?
Find the area of one of the lateral faces and then multiply by 6.
I like it. What shape is the lateral area? One of the lateral faces, I should say.
A rectangle.
Okay, so we got a little rectangle here that is 6 by 12. And I got how many of them, Dan?
6.
6. Area is equal to base times height, so that's 6 times 12 times 6. So 6 times 12 is 72 times 6 is 432. 432 what? Centimeters squared. Okay. Pretty easy. If you use the other technique though, you have to change the formula. So the formula was 2b plus pH. In this case, we're just looking for the lateral area, so what part of that formula would we get rid of?
2B.
Or not 2b? That is the question. Thanks. So we're going to use what's the perimeter?
36.
36 times the height, which is 12, and I'm guessing that 36 times 12 is 432. Okay, either method. And again, the thing I don't like about the formula is that we had to take that quote-unquote memorized formula and adapt it to this situation where this is just find the area of some rectangles. But again, I don't care which one you want to use. It's entirely up to you. Any problems with that? Okay, let's ramp it up a little bit and do some surface area then.
Hold on, I have a question.
Whoa, I don't know what just happened there, but I have to. Go ahead, ask your question.
Is 432 the whole thing?
That is just the lateral area because
Okay.
we didn't find the area of the bases.
Okay, just making sure.
For some reason, I have to do this again. I'm not sure why. Okay, we're back at it then. 432, and then this one is the surface area. Christelle, what kind of shape is that?
Triangle.
Beautiful, triangular prism. Find the surface area of that triangular prism. Find the surface area of that triangular prism. Johnny, how many faces are we dealing with? Awesome, 5. How many of those 5 faces are bases? 2. And how many of them are lateral faces?
3.
Well done. Carry on. You can answer exact or approximate, either one, it doesn't matter. It's actually easier to do the approximate value in this case. Those cucumbers? Cucumbers and lemons? I'm not. Really?
It feels like it's so good.
What does, the cucumber or the lemon?
Does it taste good?
Does it taste good?
I like
I
lemon.
had it over the
Cucumber
weekend.
water.
And I like
You had lemon cucumber over the
Yeah, my
weekend?
friend made it. It's like fresh. I really said gross. Tastes like gross. She also likes.
That was an interesting transition from it tastes really fresh to I'm excited
Well,
about
'cause-
summer.
'cause
That was
like-
very
like
random.
yours
Yeah,
fresh
I like
like
ponies.
summer.
What was that?
It's like fresh like summer, like it reminds me of like summertime.
Oh, okay,
So,
okay,
you know.
all right.
Disgusting water.
Disgusting water, right, because in the summer I like to drink out of ponds.
That's what I wrote.
Oh boy. Natalie, what do you got?
As a final answer,
Please.
I got 194.0.
Anybody else?
Oh, my bad.
Maybe you're the only one that got it right. Let's think positive.
Okay.
What'd you get, Jocelyn?
I got 161.6.
161? Maybe you're the only one that got it right.
Oh, well, yeah,
What?
that's.
You agree with her?
Yeah, that's the
Oh,
approximate.
well, how long were you gonna sit there before you said something?
I said it.
I said, I guess, I got 161.7. So I'm gonna do it first using my technique, and then I'll show you the formula technique. Let's see, get rid of that. All right. I've got two triangles to deal with. They are 5 by 6. There's two of them. Area of a triangle is 1/2 base times height, which is 1/2 6 times 5, but there's two of them, which gives me 30. And I'm gonna put a rectangle around that because I'm gonna need it in a minute. What can you tell me about the rectangles? Are they all the same?
No.
Are any of them the same? No.
Oh,
I've got three of them. One is 5 by 7. The other one is 6 by 7. And the third one is what? By 7.
square root of 61.
Square root of 61 using Pythagorean theorem. So this is times 1 is base times height. I'm going to write the formula down once. Is 7 times 5, which is 35. Put a rectangle around that. 7 times 6 is 42, rectangle around that, and then 7 times the square root of 61, put a rectangle around that. Gesundheit. Now, finding the total surface area, add all those things up. If you wanted an exact answer, you'd get 107 plus 7 square roots of 61. Which is kind of a silly answer. So you would take the approximate of 161.7. How many people use that technique? All right, the rest of you, I assume, used the formula or didn't get it.
Wait, where is 7 square root 61? Where is that?
Area of that rectangle. On the problem, it would be that rectangle up on top. Because
How
we
do
had
you
to
know it's
find
square root right. Okay, so you just.
5 squared plus 6 squared equals x squared.
Oh, okay. Okay.
The other technique then, we would do the formula. The surface area would be 2b plus, you'd have to find the missing side, so we know the area of the base as a side calculation would be 30, so it would be 2 times 30. But again, you'd have to come over here and do areas equal to 1/2 base times height, which is 1/2 6 times 5. Whoops, it's not 30, it's 15. And then the perimeter would be 11 plus the square root of 61, all of that times the height, which is 7. Again, showing your Pythagorean theorem calculation there would get that done. This seems like an easier method, and again, if you like this method, then by all means, feel free to use it. How am I going to find the surface area of that thing, that cylinder? Alyssa?
Well, if you draw on that, then you would find, like, that'll help you with, if you draw that, then, yes, then you'd find just the area of the rectangle and then the area of the two circles.
Okay.
Oh, is that an oval?
I'm sorry?
Is that an oval, not a circle? Oh, okay.
It's supposed to be a circle. It's a little distorted there. So we can, yes, sir?
Oh, sure.
We have a formula first. This is the same formula we just used, 2b plus, except we changed it a little bit. B in this case is pi r squared. P in this case is not p, it's circumference. So you actually get 2b plus ch instead of 2b plus. If you're a formula fan. If you're not, then as Alyssa said, find the area of this rectangle, find the area of one of the circles and multiply by 2. Add all that up, you're good to go. Does anybody know what time this period's over? 50? Oh, okay, let's pick it up. Let's start with that one. Lateral area of a cylinder with a diameter of 10 and a height of 12. You might also want to practice drawing a cylinder in your notes. If you want to make it look all fancy in 3D, you have to squish down one of the circles, so you get something like this. And if you're feeling saucy, you can add the dashed line in the back. So if you're using a formula, you got to take the formula and change it to fit the situation. In this one, if we use the surface technique, I have a rectangle. What are the dimensions of that rectangle? George?
10 pi by 12.
10 pi times 12. Where'd the 10 pi come from?
Circumference.
Circumference. Good. So the area of that rectangle then, which would be our lateral area, would be base times height. So 10 pi times 12, which would give us a $1.20 pi. Centimeters squared. Pregunta?
When it talks about the, when it's saying like the diameter and the height, is it talking about that middle part, not the bases?
It's talking about the diameter of the cylinder itself, which would be the diameter of the base.
Okay,
Does that answer your question?
yeah.
Okay, good. Any problems with that? Hot diggity. Let's do a surface area problem then. Calculate the surface area of that cylinder. Question?
So does the formula have to change for cylinder or no?
Yeah,
Okay,
because
like-
B now becomes pi r squared, and
No, I mean like, you know how in the surface area of prisms, you said you have to change formula to fit the shape?
Mhm.
So you don't have to do that for cylinder though, right? This formula always pretty.
The formula that I gave you a couple slides ago would work. This one,
Yeah,
yeah. But this is the other formula changed, so I did change it to get that. This will
Oh.
always work for a cylinder if you're looking for a surface area, but you have to adapt it if you're only doing a lateral area. To me, that gets really confusing, so I just like to break it into surfaces.
okay.
Yeah, that's right.
Three 368 pi inches squared?
Yeah,
Is that right? Okay. And again, I did it by breaking in the surfaces. I know that the rectangle is going to have a height of 15 and a length of the circumference. So I did the circumference calculation up here. 2 pi r gives me 16 pi. So the area of that is 15 times 16 pi, which is 240. I got two circles, a top and a bottom. Pi r squared, 64 pi times 2 is $1.28. Add all that up, and you get 268 pi, or whatever the decimal equivalent of that would be, which is...
oh, I don't know, I was gonna say, are we always gonna keep an exact form, or we have to do a decimal?
It depends on the problem.
Okay,
Since I didn't specify in this case, either one would be acceptable. What's 368 times pi, someone?
1,156.1.
Thank you. 1,156.1.
Yes.
Okay, beautiful. Okay, doke. One last thing, cross sections. We're going to be taking our three-dimensional figures and slicing them. And when you slice them and open them up, you have a two-dimensional figure. So for instance, if you take an orange and you cut an orange in half and you open it up, what two-dimensional shape are you looking at? A circle, correct. Okay. Suppose you take, trying to think of other geometric shapes you would chop in half. Well, regardless, here I have some examples. Here's a pyramid, and you can slice it different ways, and out of that pyramid you can get different shapes. So slice it horizontally, you get a square. Slice it at an angle, you get a trapezoid. Slice it a different way, you get a triangle. Okay? Day 1 for tomorrow.